You are watching Radicon. Based on soil composition and abundance of radioactive elements, different cities in the world can have large amount of background natural radiation. A comparative study of global radiation map is quite surprising. The chart shows that Ramsar, Iran residents can have maximum radiation dose of 260 milligray every year, while world average is 0.82 milligray every year. This indeed is a very large variation. In UAE, background natural radiation is low. With upcoming nuclear plant in Baraka region of UAE, FANAR has been proactive to monitor its radiation impact. Between January 1 and December 31, 2015, hundreds of samples were collected by 17 different monitoring stations. There were 78 samples of soil and water, cucumber, and date palm fruit collected and analyzed in the laboratory. In addition, more than a million individual measurements of gamma dose rates were collected from a network of monitoring stations, while more than 600 measurements were obtained using portable high-pressure ionic chambers. This is the first baseline report since establishment of FANAR in 2009. These activities are to monitor and regulate nuclear activity in the country and will be used as a comparative measure once the nuclear plant in Baraka begins operations. Different parts of the world have different proportions of radioactive materials. This fact takes us to the discussion of food and its radioactive components. Naturally, soil radioactivity passes onto food and water and adds to background natural radiation. Above chart shows common foods and a brief description of radioactive materials and level of radioactivity dose. Food contributes about 0.3 millisieverts in most part of the world per year. Another important variable is altitude. This slide describes the minimal radiation levels at sea level, measuring only 0.03 microsieverts per hour. In cities above the sea level, such as Mexico and Denver, background radiation can increase up to 0.1 microsieverts per hour. This further increases in majestic Himalayas such as K2, Pakistan, where it can be 1 microsievert per hour. At the height of 10,000 meters, an altitude used by several aeroplanes, background radiation can be 5 microsievert per hour, while a higher altitude flight at 16,000 meters can double the radiation dose due to cosmic rays. This is a beautiful illustration by Ministry of Environment, Government of Japan on comparison of natural and artificial radiation sources and relevant doses. One can see dental imaging and chest radiation doses on the left hand are very low, far below the annual background radiation shown on the right side. Hence, these examinations have no direct impact on increasing radiation doses of population. That is result of incredible work done by imaging industry and health professionals to achieve such safe levels of radiation exposure. As we move upward the spectrum, we see higher levels of radiation from artificial and natural sources. It is very striking that living in Ramsar, Iran could be equal to a full body CT scan in terms of radiation dose approaching 10 millisieverts.
You can subscribe to our YouTube channel and click on the notification bell for new courses. For more modules and Radiology CMEs, please visit www.radicon.org.